Hello students, this is Mr. Ezra. Today we're going to talk about some specific characteristics of polynomial functions. So we're going to talk about when the function is increasing, when it is decreasing, and something called extrema. When we talk about these kind of functions increasing or decreasing, or we'll also talk about something about when the function is constant. We're going to use interval notation for that, so we'll have to kind of remember how to use interval notation, and we'll get into the specifics in just a moment. We're also going to talk about minimums and maximums. That word extrema is a Mathemese word for maximums and minimums, and there's different types of maxes and different types of min, so we'll get into that today as well. Let's start with intervals of increase, decrease, and constant. So when you read a graph, you read it from left to right. When we talk about an interval of decrease, we're basically saying if you're like starting on the left, it's decreasing if you go left to right and it's going downhill. It's constant if it's flat, if it's not going up or not going down, but just horizontal. And it's increasing from left to right if it's going uphill from left to right. And it can be steep or not steep, but if it's going up from left to right, then it is increasing. To describe these intervals, we only use the domain of the function. So we're kind of like saying from left to right, where is the function decreasing? We don't really care how far down the graph it's decreasing or how far up the graph it's decreasing. Instead, what we're describing is from left to right, where is it decreasing? So we want to make sure that we look at spots where it changes direction or it changes its behavior, and we want to look at the x values of those spots. So in this example here, it's decreasing until it gets to an x value of 0, and then it's constant until it gets to an x value of 2, and then it starts to increase again. And those x values, those domain values, are what we're going to use to describe those intervals, and we just put it in interval notation. So this function would be decreasing from negative infinity to 0. It would be a constant function, or an interval that is constant from 0 to 2. And then it would have an increasing interval from 2 to infinity, where from left to right, from 2 to infinity, the function is going uphill. And as long as you can remember that, these questions are usually pretty simple. It's just kind of getting used to thinking of it as left to right. Where is it doing that thing that it's doing? Where is it decreasing? Where is it increasing? We have to use those x values to describe that. These are intervals. They're intervals. So they're describing distance from left to right, from negative infinity to 0, from 0 to 2, and from 2 to infinity. And these intervals will always get parentheses. You'll never use brackets for these intervals of increase, decrease, or constant intervals. Another example here, this is an actual polynomial function where you can see from left to right it's going uphill, so it's increasing until it gets to an x value of 1, or sorry, negative 1. At negative 1, it changes direction. It's no longer increasing. Now it's going downhill. It's decreasing. So along the x-axis, it's decreasing from negative 1 to positive 1. So it's going downhill from negative 1 to positive 1. And then it goes uphill again. It's increasing again from 1 to infinity. So to write out those intervals, we would say that this is increasing from negative infinity to negative 1. It is decreasing from negative 1 to 1, and then increasing again from 1 to infinity. So it has two intervals of increase. The first interval is from negative 1 infinity to negative 1. The second interval of increase is from 1 to infinity, and then we only have one interval of decrease. And that's basically it. And I've added some kind of lines here to break up the graph and some shading with some highlighters so that you can see the differences. But you just have to remember, like, what is the x value where it changes direction? What is the domain value where it changes direction? As long as you kind of identify those, finding these intervals can be fairly simple. So increasing and decreasing is stated in terms of the domain. That's super important for you to remember. It's the most common mistake that students make here. They want to use something else. All right, let's look at another one. This is not a polynomial function. It's a different type of function, but it's got an increasing interval that looks to be linear, and then a constant interval that's linear, and then a decreasing interval that's linear. And you can see that I've identified the domain from negative infinity to 0. It's increasing. Increasing. From 0 to 2, it is a constant function. Constant means it's not going up or down. It's remaining the same throughout, from 0 to 2. And for a domain from 2 or x values from 2 to infinity, or in other words, 2 ever to the right, it's going from, it's decreasing from 2 to infinity. And I added arrows at the end of these, but remember when you get to your practice, let's say there's not an arrow. As long as it goes all the way to the edge of the graph, there's an implied arrow there. Just make sure that you notice that, I guess. All right, we've got another example here. This is actually kind of a strange function. You haven't seen many like this year yet, but this has part of a function that seems to be parabolic or quadratic, and then it changes to a different type of function that seems to be linear. And this is what we call a piecewise function. It's more than one function kind of pieced together. We see that it's left to right decreasing from negative infinity to 0. That's the domain along which it's decreasing. So negative infinity to 0 is the first interval. It then begins to increase. It's going uphill. It changes direction here at 0, and it's increasing forever to 2. From 0 to 2, the function is going up. It's increasing from 0 to 2. And then at 2, you notice it picks up down here again, and it starts to decrease again, forever down, forever going down, forever decreasing. So that's going to be domain values from 2 to positive infinity. So that's decreasing. So I'm going to put a union here and say 2 comma infinity. So that allows me to say that it's decreasing from negative infinity to 0, as well as 2 comma infinity. And this is a symbol that means union, so it just kind of allows us to connect these two intervals together. Another term that we want to pull into our vocabulary is something called extrema. Extrema is the fancy word for minimums and maximums, and we'll learn that there are two different types of mins and maxes. The first type is called a relative minimum and maximum. And probably most of the time I will say relative in this class, but you should notice and note in your notes that sometimes you'll see this called a local minimum or maximum. It's not always called relative. It depends on the textbook or the teacher. And you can think of these relative minimums or local minimums and maximums as where the function changes direction, especially in a polynomial function. So you'll notice that it's decreasing, it changes direction here. That is a local extrema. And then it's increasing and it changes direction here. That's another local extrema. Every place that it changes direction is a relative or local minimum or maximum. So when I'm asking you for a relative minimum, what I want is a list of all of the lowest points, every single one of them. So this function here has 3 relative minimums because there are 3 places where it changes directions that are the lowest at that part of the graph, like local to that part of the graph, it's a minimum. I sometimes call these valleys, like all the valleys, the very bottom of the valley is a relative minimum. And the relative maximums are the hilltops then. They are where the function is increasing and it changes direction and starts decreasing. And every single one of those places is called a relative maximum. So there can be many relative minimums and there can be many relative maximums, or there can be one or none. It just depends on whether or not there's that kind of change in direction in the function. And when you list these out in a minute, you'll see that you list them out as the coordinates of the point that is that minimum or is that maximum. It is a point on the graph, a point on the coordinate plane. The absolute minimum and maximum is a little bit different. We also sometimes call this the global minimum or the global maximum. And this is not where the function changes direction, but it is instead the absolute lowest point on the graph. In this case, this is the lowest point down here, this blue dot that I have, and this pink dot up here is the highest point on the graph. Those are what are called absolute maximums and absolute minimums, and they're a different type of extrema. So in this example here, we're looking for relative maximums and mins first, and we see that there's a change in direction, a hilltop. It's increasing and it changes direction to decreasing, and that relative maximum is at the coordinate -1, 2. So we'd say the relative max is -1, 2. This is a coordinate, a point on the coordinate plane. And the relative minimum, the valley that we see here, is at +1, -2. And that would be the relative minimum. Since there is an arrow up There's no absolute maximum, and since there's an arrow down, there's no absolute minimum. You see, a minimum or a maximum is a point on the coordinate plane, and if there's no absolutely highest point, then you have no absolute max. It increases forever towards infinity, but never gets there. So there's no point that would be the highest point. So let's look at a full example where we're looking at lots of different characteristics and seeing if we can remember and describe them all. Remember that anytime your function approaches the edge of the graph, and you're going to assume that that's an arrow. Okay, so I have arrow up and arrow down, and I see a graph that's increasing, decreasing, and then increasing again. The domain here, remember the domain of all polynomial functions is the same. You can write it as negative infinity to positive infinity, or all real numbers. You don't have to write them both to choose one. The range, since we have an arrow down and an arrow up, our possible y values on this function are also all real numbers. So if I can do a better job with the all real number symbol, or you could write it in interval notation from negative infinity to positive infinity. Remember, zeros are like x-intercepts. They are where the function touches the where the function touches the x-axis or crosses the x-axis. If it bounces off, that's an indication of a double root or a double zero. So this -2 is going to be counted twice as a 0. But where it crosses here at +1 is only going to be counted once. The y-intercept on this graph is down here where it crosses the y-axis. There's x, there's y. The y-axis down here at 0, -4. And since it asks for the y-intercept, I'm going to list it as a coordinate, 0, -4. These are older characteristics that we've already talked about in videos and practice, and now we're adding some new things here. Is there an absolute maximum or minimum on this graph? Well, there's an arrow down, so there's no absolute minimum, and there's an arrow up, so there's no absolute maximum, so there is none. In this graph, no absolute max, no absolute min. But in this graph, there is a change in direction of increasing to decreasing, which is like a hilltop, which is a relative max. And there is a valley down here, which would be a relative min, relative minimum. So let's list those out here. The max would be the coordinate -2, 0. And the minimum would be the coordinate 0, -4. Okay. Now for increasing and decreasing, I like to kind of break my graph up where it changes direction. And I put a little key at the top that I can see that from negative infinity, the first time it changes direction is here at an x value of -2, and then it's decreasing, so it's increasing here, right? Increasing, going up from negative infinity to -2. From -2 to 0, it's decreasing. And then from 0 forever to the right, it's going uphill. From 0 on the x-axis to the right forever towards infinity, it's increasing. Remember, you have to describe these intervals of increase and decrease with your domain, with your x values. It doesn't matter how far up or down the graph it goes. You only use x values. So here, I'm increasing from negative infinity to -2. And I am also increasing from 0 to infinity. Put a union between those two. And I am decreasing from -2 to 0. Along the x-axis between here and here, my function is going down. I think this is our final example today. Just to review really quickly, remember that these are arrows. If it goes to the edge, assume that it's an arrow. Okay, so our domain is all real numbers. Arrow on the left, arrow on the right. But our range in this case is not all real numbers because there's not an arrow down. There's a lower boundary, a lowest point on the graph at a y value of -4. And remember, that gets a bracket because it is part of the function. It's on the function right here, -4. And then the y values, we have arrows up. So we'd say from bottom to top, our function has y values, has a range of -4 to positive infinity. There are two zeros, two places where the function crosses the x-axis at -2 and +2. Y-intercept, we see it crosses the y-axis down here at 0, comma, -4. Is there an absolute maximum? Well, arrow up means no. Is there an absolute minimum? Well, there is a lowest point on the graph. This is the lowest point, so there is an absolute minimum here. And that absolute minimum would be at the coordinate of 0, comma, -4. Okay, what about relative? Well, a relative max is like a hilltop, right? Where it's going up and it changes direction and starts going down. We don't see that on this graph, so there's no relative max here. But there is a relative minimum here. And that relative minimum is where it's going down and it changes direction, and then it starts to go up again. So not only is this a relative min, it's also an absolute min, so it's both. It meets both definitions. It changes direction here, and it also is the lowest point on the graph, and that's okay. Sometimes it can be both. Often it is. Okay. When we are deciding how to break this up, I see that this function is decreasing from -infinity to 0. That's the x value here. And then it's increasing forever from 0 to positive infinity. So I'm increasing from 0 to infinity. And I'm decreasing from -infinity to 0. Okay. And I can see where all of these representations of answers might get confusing, and you just have to get used to the fact that we use parentheses to represent intervals, but we also use parentheses to represent coordinates, and you need to know what you're looking for. Are you describing a coordinate or are you describing an interval? Now, there are other ways to write these intervals of increase and decrease. For example, I could say that it is increasing from all x values greater than 0. Oops. And that it is decreasing for all x values that are less than 0. But you'll see that I don't use this notation very much in class. I prefer that you use interval notation, that you get used to that interval notation, because we kind of use it interchangeably in lots of different situations, and I just want you to practice that notation. But you could see it written another way and it would mean the same thing. Well, that is it for today. I hope that you're able to make sense of this, and as you begin your practice, you don't have too many issues, too many problems. I'll see you in class.